Okay, we are doing lesson 7. And I did hit record, so.
Yay!
Yo, Jay, switch pop it. No, it's
Wait, should I be the one to make sure?
Ben, please come back.
Should I be the one to make sure that it's
Come back!
I see this square, right? The square means when we're recording.
Ben,
Yes.
don't come back.
Come back!
Please. Ben,
Okay,
we miss
we are going to multiply
Don't come back, we miss you.
decimals.
The
Remember,
I is still in the normally.
you guys remember the rule for multiplying decimals? What did we talk about? Yes. You do it normally, but then what do you do with the decimals?
You do it normally. Mark them up together.
Okay, that's when you're adding. So you line up the decimals, but what do you do with the decimals in a multiplication problem?
Oh, you
add them together.
You
however
put
many
the in
place
place
value.
Yes, Nathan?
The place value. You, whatever the place value is how many decimals you put over to the left.
Okay, but if you're multiplying 2 decimal numbers, what do you do with those 2 number of place values? What do you do?
I don't know. That's too complex.
Anyone remember? Or maybe we didn't even talk about it.
Put 2 places to the left.
I don't think you talked
If it's 2 places to the left, what if you're okay? Let's just try a decimal problem. Okay, so let's say I'm going to multiply these guys, 4.12 times 63.2.
Ooh, I know.
All right. So first step, you don't have to line up the decimals. Don't do that. Just line them up normally, so you can kind of justify it, right? So make sure they're all squished over on this side. But and then what, Austin?
Then you divide. No, multiply.
Multiply. So remember, 2 times everything. So 4, 2, 8, and then don't forget that spacer there. That 0. Yes.
You put the decimal in the wrong place.
Well, no. This is what the problem is. I want to know what 4.12 times 63.2 is. Okay. So this is when you're multiplying. You don't have to line up the decimals. Okay, you just multiply normally.
No.
All right.
But
So now the 3 times 2 is 6. 3 times 1 is 3. 3 times 4 is 12. What were you gonna say, Xavier? I cut you off.
it looks like it's 63.02.
It does?
It does because it looks
Oh,
like
like there's too much space there?
yeah.
Oh, okay. Well, yeah, and it's not terribly important to line it up like that because you're just multiplying this by everything, this by everything, and this by everything. So they don't really have to be lined up, but it does make me feel better when it's lined up like that. Okay, remember in the third row you need 2 zeros because this is actually multiplying by 600, right? 6 times 2 is 12, carry the 1. 6 plus 1 is 7. 6 times 4 is 24. Add them up. This is all just multiplying normally. And then where do you put the decimal? Is it coming back to you now? Ammo, where do you put the decimal?
You count how many spaces to the right of the decimal point there are, and then you
So there's 2 spaces there,
and then there's 1 space at the bottom
1 space
number.
there.
Then you start at the very first number and you move 3 spaces.
Yes, so you're basically adding the total, counting the total number of decimal spaces. Do you see that? See how there's 2 in this number? And there's 1 in this number? So there's got to be 3 in your final number, so you're going to put it right here. 1, 2, 3.
Normally.
Okay? Does that make sense?
Just do it normally.
Just multiply normally and then figure out your decimal point, where you put your decimal point at the end. So you can ignore the decimals when you're multiplying, and you just have to deal with them at the end. You have to count the total number of decimal places. Okay? You guys remember that?
Yeah.
Now, here's a fast way to see if you put the decimal in the right place. We're going to ish this. Remember, 4.12 is about what?
1.5.
It's about 4, right? It's 4-ish. Okay?
4-ish.
So 4-ish.
Forest.
What's 4-ish times, this is about 60-ish, right?
Yeah.
What's 4-ish times 60-ish?
200
So 6 times 4 is 24. So 60 times 4 is what?
240.
240-ish. All right. Is 260 about 240-ish? Or is 20? So this is how you tell if you put the decimal in the right place. If I would have put the decimal there, it would have been 26 point something, which is not 240-ish, right? And if I would have put the decimal over here, it would have been 2,600 something, right? That's definitely not 240-ish, but 260 point something
Mr. Flack,
is more
you said
240-ish.
240-ish.
Did I?
Yes.
Yes.
I don't think
Watch
so.
it in the recording. Watch it
All
in
right.
the recording.
I'm gonna play back that recording to see if I said and. Okay, so this is an update for those of you viewing at home. Xavier was wrong. I didn't say and. But if you want to listen to the video back and judge for yourself, I said 240-ish, which if you say it fast, it sounds like in there, but it's not. Okay? But, you know, we'll take a vote. We'll take a vote. And if you guys think that I said and, then I'm going to give Xavier a free problem set.
No, all of ours.
Okay? So there's got to be a vote. So you can go on, comment on this assignment and whether you think I said and or not. And whoever wins, I'm going to give Xavier a free problem set if you think I said and. But if you do think that, you're wrong, but majority votes. Majority wins. Okay? So moving on.
Schoology, please respond. I want to get less homework.
Will you stand with Xavier in this quest for a free problem set? Okay.
Am I going to have to take this to the district attorney?
Let's try one. Let's have you guys try this problem and see if you get it right, okay? No. So I'm going to go 34.6 times 0.7. Go. Do that math.
I think I should get my notebook out.
Do the math. Do the math. All right? 34.6 times 0.7. Do that math. Go. Don't do it on a calculator. Can't use a calculator until second semester.
Okay, I did it in my head and I get.
Are you going to keep that in there?
Of course.
I did it in my head also.
I'm really in my head right now.
Nathan, do you have an answer?
It looks like a
6.92.
6.92 is what Nathan got.
I got 6.92.
I did it in my head also. That should
What'd
be
you get?
That should be a free problem set.
24.22.
24.22. You said 22. Anyone else?
I'm doing it in my head, okay?
You're
Except
doing it in your
looks like
head?
a 2, so I keep thinking it's a 2, but it's
I
a
did it in
7.
my head.
I got 24.22.
24.22. So we got two 24.22s.
I said we got 24.25.
All right, let's see who's right. So we're going to ignore the decimals, right? What's 6 times 7?
42.
42. Carry the 4. 7 times 4 is 28. Plus 4 is 32. Carry the 3 times 21, 24. Right? Is that what you guys got?
I got that.
Now, where do you put the decimal?
So there's one. So at the behind the decimal, there's one. So then you have to go 2 more.
So yeah, there's one here and there's one here,
Yeah.
right?
So then you add that, and then that is.
So now we go 2 places. So we add that. So there's got to be 2 in this. So 24.22.
See, well, like, that was my second guess.
All right, right. No, that was your first guess, but you just
So I changed it.
yeah.
Yeah.
You're good.
Yeah.
Okay, moving on. So this is multiplication. Can you guys remember the rule for multiplication?
Do it normally.
Probably.
Do it normally.
All right. What if you are dividing? Let's do division. What if you're dividing by decimals? So let's say I've got 10 divided by 0.5.
You move the decimal point so that it looks like a normal 5.
Right. So here's the rule for dividing decimals. Don't do it. So change that decimal to a natural number. Okay, so we're going to move it. But you can do that as long as you do the same thing to this, right? Because this is like a division problem, so it could look like this. You see that? So the same division problem, I could multiply both the top and the bottom by 10. What happens when you multiply a decimal by 10? You guys remember this rule?
You You added the place value?
You just move the decimal over one place. And the same thing here, move the decimal over here. Adding a natural number by 10 is just adding a 0, right?
Oh, Mr.
So
Flack.
what's 100 divided by 5? How many nickels are in a buck?
50.
20.
20. Yes, Nathan, what were you going to say?
I know, because on the multiplication I did 34.6 times 2. That's
Oh, got it. Good catch.
I wasn't even thinking about the number. I just said 20 randomly. And
I think
it
Xavier
All right, so this is the same division problem as this. So do you see how we just moved that and moved this, and that's okay. So we add a 0, put the decimal there, and remember when you're dividing decimals, you just bring the decimal up from the dividend up to your answer, okay? So now we just divide normally. How many times does 5 go into 1?
0.
0. So how many times does 5 go into 10?
2.
2. So see how there's one more place we have to fill. So 2 times 5 is 10. And then how many times does 5 go into 0?
0.
0. So we need that 0 there. So we get the same answer. So 10 divided by 0.5 is the same thing as 100 divided by 5. All we did was move the decimal over in both the top and the bottom, or the inside and the outside. Same thing. Okay? So let's see if you guys can do this problem on your own. Yes, Xavier.
I know speaking of broken English.
Okay, great.
Speaking of English.
Awesome.
I know speaking of broken English.
The broken English.
When?
I have
Broken the English.
I have good English.
I have the
Good
best race.
Okay, let's see if you guys can do this division problem.
Okay, is it first to do it gets a cookie?
If I had a cookie, I'd give it to you.
Okay.
After I took a bite out of it, of course.
COVID.
That's right. Yeah, my special COVID cookie.
8.
Blip, 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 blip.
What are we?
Okay, we're doing this division problem. Go, 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 go.
Wait, so if we move the 35 over twice to make it 35 point, then do we move the other decimal over twice?
Yep, that's it.
So it's 008.4.
Yep.
Are we doing remainders or?
Now, good question. So you'll see that once you get to the end of this, there's no more digits, but guess what? You can add as many zeros as you want. So go until it stops. Till you get a 0 remainder. So you can remember in the decimal number, you can keep adding zeros as long as you want. You don't need this many zeros, by the way, but you will eventually stop, which is nice. So you should get a nice, pretty answer. All right, Nathan, did you get an answer?
Yeah, I just got 2.0 with the 0 repeating.
Okay.
Was it? No.
Any other answers? Are you doing this, Xavier?
I can't get my pencil. So
If
I'm
only,
trying to do this.
if only you could get up and get it.
I don't want to put this on the floor.
Yeah, it is a hassle to get up.
It's
and
a
down.
monster. It's a monster writer.
It is. All right, you guys need more time?
Yes.
Yes.
Okay.
You're slow. Oh no, I think I got it wrong.
I think I don't remember.
What'd you get?
I wish you would have dropped it and it went to the same spot.
Done.
I think that first guess
What
was
did you
wrong.
get?
So it doesn't go in 3 times. That's too much.
Yeah, I wanted to use my calculator to just do timing for 35, but
Yeah. Did
I
you get an
got-
answer? What'd you
Yeah,
get?
I got 0.243146.
Okay. Any other answers?
I need a minute.
Wait, I did something really wrong again. Hold up. Pause. What did I do?
What did you do?
I don't know. What did I do, Emerson?
I don't know. I don't know. I'm not in your head.
Okay,
Okay.
What'd you get?
0.21131.
It's not.
Not yet. I haven't heard the right answer yet.
What? Wait. What if it's not a beautiful number?
There's
It's
not enough
ugly?
space on my.
It's very
paper.
pretty.
I'm just gonna go
It's-
to a different
Well,
page.
some
Yep,
numbers
there's
can be
just-
very ugly.
There's just 2 digits.
It's just 8.4, guys.
Because I think most of us are gonna get very ugly numbers.
Okay, let's do what Nathan suggested first. Let's get rid of this decimal. Now you can't just go around getting rid of decimals. What else do you have to do?
Move the decimal on the inside.
Yep, so we're gonna put that right there. That means our answer is gonna have it right there. And now we start at the beginning. How many times is 35 going to 0?
2.
0. How many times is it going to 0, 0?
Yeah.
How many times is it going to 8? Still 0. How many times is it going to 84?
2.
2.
2 times. What's 2 times 35?
Hold up, I'll get the answer.
80.
No, 7.
70. Subtract.
That's why I did
You
it
get
wrong.
14. Then what do you do?
That's
Add
why I
a
did it
0.
wrong.
Bring down the next digit, which remember, you can add as many zeros as you want after the decimal point. Okay, so how many times is 35 going to 140?
answer.
What'd you get?
0.240.
That's right. So now you can trim off all the zeros on the end. You don't need this. So this is all you need, 0.24. Because 4 times 35 is exactly 140, and then you get 0. So you can stop right there.
Oh,
What if you want
I
to
know
keep
it.
going?
Emerson's in thought.
Well, then you would just keep getting zeros, right?
Stupid.
So you don't have to do
dumb,
that.
you're Stupid.
So
So
what?
if you get a 0
But
remainder, you're
why?
done.
That's too far.
Unless there's more digits before the decimal that you have to fill in. But there's not. So now you're after the decimal, so you're just going to stop whenever you get a 0 remainder or when you find a repeating pattern. And we'll talk about that later.
What
Yes.
if you want to keep going and you do with nothing but zeros?
Well, that's called
You took the Garfield knife.
being insane.
It's a
The
lie.
definition of insanity
That
is doing the same thing over and over again,
Why are you?
expecting different results. So if you want to be insane, you're welcome to do that. Okay?
Remember this game lost?
So.
All right. So how about we ish this? So estimation, there's a difference between estimation and rounding.
Dishes.
Okay, so let me try to explain the difference between estimation and rounding. When you round to a specific place value. Like we say, we can round the same number to the nearest tens, nearest hundreds, nearest thousands, right? But when you say round, you have to finish the sentence. You can't say round that, right? You have to say round it to this value or this place value, right?
Nearest?
But when you say estimate, you can just say estimate it. Because here's what you're doing when you're estimating. You're estimating to the first digit.
No.
That's what you're doing. You're estimating to the first digit. So for example, the first digit here is 4. And you estimate to the nearest ones, right? And that's 4. The first digit here is 6. And that is in the tens value, so you're rounding to the nearest tens. Okay? So that's why it was 4-ish times 60-ish.
Okay.
Okay.
Okay? So do you guys understand the difference between rounding and estimating?
Yes.
All right, so let's try ishing this, okay? Let's try ishing this. So let's estimate this problem. Estimate 912.0039 minus 8.93. So let's estimate these two numbers and then let's do that easy subtraction problem. What is how do you estimate this first number? Where are you rounding to?
912-ish.
So what's estimating?
Educated guess.
Yes, but specifically when you're asked to estimate, you're going to round to the first digit's place value. So what's the first digit in that number?
9.
9. So 9 is in the hundreds place value, right? So round to the nearest hundreds.
90. That way. I mean,
So the nearest hundreds?
Yeah.
100.
So what's 912.0039 to the nearest hundreds?
1,100.
Well,
Seven.
no, because it's
900.
912.
It'd be 900.
Remember, if I'm going to round this, I need to do that. So look
That's
at the 1.
that's a 9. It looks like a 7.
I thought it was a 4.
Sorry.
It looks just
It
like a
looks like
7.
every single
Yeah,
number
yeah.
So
ever.
this is 900-ish. right? And then what's this estimated? 8.93. How do you estimate that?
The 8?
It'd just
Oh,
be
the
9.
3.
10.
So it'd be 9, right? Because you're rounding to this 1's value. So you look at the 9 and that says go up 1. So we're going to increase 1 to the 8. So 900-ish minus 9-ish. So what is that? 891-ish.
Yeah.
I got here.
Okay? So that's estimating. And then you can even estimate that answer to 900-ish. But if you estimate first and then do your math, that kind of gives you a quick answer. But sometimes you're doing it. Like when I go on an elevator and I see maximum weight is 10,000 pounds, and I'm looking at all these larger people that are waiting for the elevator, I'm going to estimate, okay? And I'm going to say, okay, 200 pounds, 300 pounds, ooh, 400 pounds.
You definitely.
And then I'm gonna okay, and then I'm adding it up.
That
Okay,
is-
I'm probably still okay, but just to be safe, I'm gonna take the stairs. Okay.
That's not okay.
Definitely.
That
No.
is not okay.
You
Like,
need
no,
to.
no.
You don't need to tell people how much you think they weigh, but it's sometimes
No,
it's safe.
It's PC. You need to be PC if
Right.
you're gonna post this on YouTube.
But you can't. Oh, I guess I am filming it. But tell me you don't do that. If it's an older elevator and it's only like 1,000 pounds,
I'm a
No, I'm not.
Maximum
getting on
weight?
that elevator.
I'm not.
please,
Get on
for
it.
your own safety, estimate and profile them in your head. Okay? You don't have to tell them out loud. I'm like, excuse me, before I get on this elevator, can you tell me your weight, please? That's what's gonna happen.
500.
Okay? No one's gonna tell you your weight, but you can, for your own safety, please figure out how much they weigh. Yes, sir.
Can I go to the bathroom?
Yes, she's gonna lose a little weight right now. Okay?
I feel about 10 pounds lighter.
All right, so that was lesson 7. We are gonna move on to lesson 8.
Black man, give me some math and I'll give you some flack. Black man.